Hello everyone, my name is Satya, and here we are presenting our project weather forecasting for Pune, India, using a machine learning model, specifically XGBoost model. We will go through each and every step and each and every pipeline that we will be explaining that why XGBoost it was chosen over the model like random forest. So here, me, Satya, and Prince, as a team member, we have performed these weather forecasting and we will be explaining each and everything. So let's get started. Next slide. So, explaining to the problem statement, like despite of the advancement in the technology, accurate weather prediction remains a significant challenge. Traditional forecasting methods often rely on the historical data, generalizing model, which can lead to inaccuracies, especially in the rapidly changing weather condition. So, in sense, the main need for the reliable and precise weather forecasting has never been more crucial. And for the solution of the same, to address this pressing issue, we have developed an advanced weather forecasting system tailored explicitly for the Pune. Utilizing the machine learning techniques, unlike traditional methods, by system leverages a vast amount of real time data, including the historical weather patterns and atmospheres and conditions. So here we are going to demonstrate everything. So next thing. Explaining about the machine learning model that we have performed, the data collection was the very much hectic task that we have done and very successfully. So we have started collecting the historical data from the Meteostat API. We fetched the daily data based on like temperature, wind speed, precipitation, pressure, minimum temperature, maximum temperature, etc. Feature engineering, talking about the feature engineering, to make the raw data into more usable format, we use feature engineering, some key transformation, including like creating forecast target, next day's weather, and adding time-based features such as month, day, year, day of year, and season. Introducing to the monsoon flags for June to September. Calculating the normalized precipitation probability also. So these steps is actually helping the model to learn underlying the patterns more effectively. Talking about the data preparation that we prepared the data for the machine learning prediction, machine learning model. Temperature was the regression task. The precipitation probability also in considered also came under the regression one. Weather condition, which is actually a classifier. So to address class imbalance in the classification task, we actually apply the oversampling to ensure the model gets enough rainy days, for an example. So here are the some here in the picture we can see that there are some modules which are installed and the accurate step of getting the data from the Meteostat. Next slide. Talking about the model training. Here we train the model like XGBoost. We use the XGBoost regressor for the temperature precipitation task, XGB classifier for predicting the weather, as it is the categorical data. And each model uses the 10 estimators or the decision tree, we can say, to capture the complex patterns in the historic data and also for the prediction of or forecasting. So model evaluation. So here, talking about why exactly we use random forest, XGBoost over random forest. Here we have performed both the models and we get the accuracy score of 87.08% for the XGBoost, whereas 87.88% for the random one. Even if the random forest is getting 0.88% more, but we are actually heading toward the XGBoost as for the future need. The RSME temperature is showing that 0.94 degrees Celsius, whereas the precipitation RSME is showing that 0.017. Weather classification accuracy is 87.08% that I have mentioned here. The precipitation interpretation of the RSME that is 0.90%. In an average, our model is actually only 0.90 unit away from the actual values. So here we can say that our model is actually predicting the actually predicting the corrected forecasted weather information. In our case, the predicting temperature in Celsius, our model is predicting the temperature which average error less than 1 degree Celsius. That's considered very accurate in real world weather forecasting. We also use the confusion matrix here. And again, talking about why exactly XGBoost over random forest. So model performance accuracy. So for our weather prediction system, we use XGBoost for the regression, temperature, and classification for the weather condition. This model achieves 0.94 degrees Celsius as a temperature, achieve temperature that is very accurate. More is the lower is the RSME, more is the accuracy. We know that. So the accuracy demonstrated 87%, which is very good to go for forecasting any weather, any day weather. So talking about to the RSME was matrices like MAE because it penalized the large error more than heavily, which is the critical for reliable weather prediction. This result confirmed the XGBoost superiority over the alternative models like random forest, which are for a use case, and balancing the speed, scalability, and the accuracy. For the future work, we will explore the transformers based model for the further enhancing long range forecast. So knowing about everything, there is a one most important question, that why exactly the XGBoost is we are using the XGBoost, even though the accuracy level of random forest is very much more than the XGBoost. So here is the well-defined answer from me. So the regularization of the XGBoost is very much accurate. So XGBoost prevent the overfitting of L1 and L2 penalties. Also, missing values. The handling missing values is important, and in random forest, we are not readily get that particular uh, what we say, that particular feature from the random forest, where in XGBoost the handling of the missing values is automatic, and also the optimization is very less, which actually very important, where the faster training speed in parallel computation is used, and which is very important. Also hyperparameter tuning, which is for more flexible or for the better performance which is highly accurate and well trained for the future work also. So specifically, it is very good for the weather forecasting, that till now we have research over here that what exactly model we need to use. So we get to know that it handles both numerical and categorical feature very well, the XGBoost, which provide the clear feature importance matrices, capture the non-linear relationship which are common in weather data. And as we are using the real-time data, there are many complexities and many patterns between them. So the performance of the XGBoost is very well, which is moderately sized, which will be applicable on the moderately sized data, like our data was really big, and also for other data. So next slide. Yeah. So talking about the correlation, that what kind of a feature that we actually put in the our model. So here is a correlation matrix, a correlation graph, which is actually saying that the temperature, min-max temperature, forecasted temperature are very similar, which is giving the which is giving 0.7 to 1% of one correlated values. Whereas humidity, monsoon status, season help to predict the rain together, which is very correlated, and we can use it for the correlation of the for the prediction of the rain, that it's raining or not. Then again, the weekly related are the precipitation and pressure, pressure, that sea level pressure, and precipitation, that is the amount of a precipitation, it independent, it is working independently. Whereas prioritizing the temperature matrices, humidity, monsoon flags, and weak but independent feature like pressure and precipitation are used in this ML model, which is very useful and useful for robust forecasting. So for the next few slide, I would like to call Prince. Over to you, Prince.
Thank you, Satya. Eh, And he in this project, we also implemented the scheduling mechanism. For first, we should understand what is a scheduling mechanism. A scheduling mechanism is a library provided by the Python, where we can update our data using some APIs or something else without manually installing or importing it. With the help of time scheduler that we implemented on the Python files, helps us in automated data updates. It helps in implementing the time scheduler at regular intervals that we want at a particular given time, whether it's in minutes, whether it is in hours, or whether it is in days. We implemented a daily time scheduler in our project. It And after that we integrated it with our ML model, that is XGBoost weather prediction model, to get us a fresh forecast based on the most recent data, ensuring that we get every day a real time update weather prediction of the historical data using the Meteostat library in the pipeline. And with the pipeline of data that we implemented improves our efficiency, that streamlined the pipeline by scheduling tasks at given regular intervals, such as data abstractions, data cleaning, feature engineering, and predicting the upcoming weeks of weather forecast as well. The technology or the library that we used was with the help of a Python schedules library, and as well as the Python time schedule library. The one which we used was the Python schedule library, which helped us in getting the real-time updates at on a daily basis. And what the outcome that we got was that the time scheduler helped us in enabling a fully automated end-to-end weather prediction system, and reinventing our machine learning model as well. And now moving forward to the future roadmap of our project, what we want to, as we know that we implemented only the weather prediction of the city Pune, but in the future we also want to implement the future predictions of many different cities or countries as well, and we want to expand it nationwide. And after that, we also would like to enable a mobile app or something other, where we can get real-time updates through the help of notifications or emails as well. And if there is a certain condition where there is a heat strokes, heat waves, or a rainy cloud that is going to happen in the upcoming days, so that we can get real-time data beforehand, and we can help us in the and we can plan ourselves in the as according to the predictions. We also implemented a streamlit app where we deployed our predictions. For this, I would like to call Sadhya, who will help us explain more about it.
Thank you, Prince. So, guys, this is our Streamlit app, the Weather Pulse advanced forecast for the project, predicting the Pune's mood swings, because even weather needs a little bit machine learning therapy. So, here is the therapy. So the current weather, that this particular dashboard is actually predicting the current matrices also, and also forecast the forward 7 to 14 days matrices, which actually forecast gives us forecasted weather. So here in the current weather, we are saying that today, just at this time, it is 28.1 degrees Celsius, whereas the precipitation is 0.0 mm, and which actually tells us that there is no chance of being raining. To get rain, and humidity is with 49%, and the weather is conditioned, so one can have their pani puri in the evening. So yeah, that's right. So let's moving forward, that here I have implemented, I have added that I want a data, forecasted data for this next 7 days, and here I get the 7 days weather forecasting. Using this particular graph, we can say that what exactly the forecasted results are shown in this way. So here we can see that there is the temperature which is raised, that today, tomorrow will be the more 1 degree rise in temperature we can see tomorrow. And here we can see the depleted graph, we can which is also towards the more temperature. So the matrices here is the precipitation probability. The what is the precipitation probability, the temperature range, the what kind of a range of the temperature, minimum temperature and average temperature. So this is the 7 days forecasting graph, particular graph. And again, on this graph, we are getting a tabular format of that 7 days data, which actually gives us the date. So here we can see that it is actually predicting or forecasting the 12th of April, 13th of April, 14th of April, 6, 15, 16, 17, and 18. So, and these are the temperature, which is actually tells us that maybe tomorrow will be more hot than today. And this is the tabular representation of the forecasted data. Again, moving toward the model performance, here we have implemented the targeted values and targeted features and the prediction that actual and between the actual and forecasted. So temperature, here we can see that the forecasted temperature and the forecasted temperature and the actual temperature, there is no much difference between them. So we can see that there are overlying or overlying. So we can know that being having the RSME as 0.90% or 0.90, it is very much good or very much accurate. So more lesser is the RSME, more is the model performance is very good. So here we can see that the actual and predicted value comparison. Again, in the precipitation tab, we can also see that what exactly the precipitation probability between the forecasted and the actual values. Here we can see that the RSME is 0.018. Again, the weather condition also, we can see that the comparison between the actual and the forecasted weather condition. Here we implemented a confusion matrix, which actually shows that how many values are true positive, how many values are true negative, how many values are true false positive, etc. So this is our confusion matrix with RSME, with accuracy score 86.42%. Again, moving further, here in the historical data weather trends, we can find the last 90 days, that is the last 3 month data trends of the temperature, again the precipitation and the weather condition, or any kind of humidity. Also humidity we can see here. So here we can see that how, in which manner actually the temperature is rises and how the temperature is lowering or decreasing. So maybe in this at this point where the temperature decreases, maybe at this point the precipitation level or the humidity level which rises, maybe there might be more chances of getting rain. So here in the choosing the matrices to visuals, we can select any matrices, like to tap on the temperature arrow. Above it, the temperature arrow. Above it. Yes, this one. Here we can see that the precipitation, humidity also. So selecting precipitation, we can see that the last 90 days precipitation, what is the trend of the precipitation. So yes, here we can see that the precipitation is between 23rd March to April of 6. So maybe here are the more chances of getting rain. Yeah. So yeah, this is the thing. And let's move forward. Also for the humidity, as compared to the as we are comparing and finding the trends, here is the humidity trends, and we also we can see that here is the humidity range at 23rd March and April 6 is at peak. So we can say that there is the more chances of raining, or there is also when we see for the precipitation, there are the peak over this point also. So yeah, and moving toward, yeah, here we have implemented two kind of a feature which will be very useful to a user. When a user wanted to grab the data that we are using it, he or she can easily download it. Again, the forecasted the download forecast data is in the CSV, that how many days, that maybe a 7 days forecasted data he have seen here, maybe 14 days forecasted data he have seen here, he or she can be downloaded here from here very easily. Also used one feature, that browsing files, that anyone can upload their files and ask this app to forecast me the weather, so it can forecast it easily, as it is a user friendly and very friendly. So talking about this application, that it is powered by the Meteostat rich historical data. This app also delivered the reliable weather forecasting with a data-driven edge. Again, built on the robust historical and cutting edge of the machine learning XGBoost, and this app provides a weather prediction that combines the science, data, and the accuracy. From 2015 to today, the historical weathers trained meets to modern AI using the XGBoost. We turn the past pattern into tomorrow's forecast. So yeah, that's it. Thank you. I would like to hand over to the Prince for the Power BI dashboard presentation. Okay. So here we have done our Power BI dashboard for Pune weather forecasting, and we have done the historic data analysis and also the forecasted data analysis. We have created the Power BI dashboard for easy understanding of the features that used in our model. In the forecasting data analysis, we grab the data from our Streamlit app and focus and analyze it using Power BI. So I would like to call Prince to explain it more.
Thank you, Satya. Now moving forward, the first dashboard gives us a quick overview of Pune's historical data. On the top left, we have got a humidity versus rainfall chart. Uh, the higher bubbles shows that when humidity is high, above 70%, we also tend to get more rainfall. Next, to the bar chart shows average rainfall over the last decade. You will notice that the rainfall has generally increased over the years, with 2021 being the wettest. On the top right, we have added a map visual to show the region we are focusing on, mainly Pune and surrounding areas like Pinri and Haveli. Below that, you will see the key stats such as the hottest day temperature, the coldest day temperature at 41.8 degrees Celsius, as well as the 5.10 degrees Celsius as the coldest. We also have the average wind speed at 7.3 km per hour and rainfall at 2.38 mm. And finally, there is a line chart showing monthly average temperatures. It peaks in May and cool off towards the end of the year, typically region weather for Pune. And now moving forward to the forecast data analysis dashboard. This dashboard shows us what we can expect in the coming week. The key highlights: maximum temperature would be around about 29.5 degrees Celsius, whereas the minimum temperature will be around about 23.5 degrees Celsius. And, and as we can see, the percentage of rainfall is zero. And in conclusion, no rain is expected at all, just clear skies as shown in the donut chart. The, the bar chart to the right shows daily predicted temperatures, which are pretty steady all week. Wind speed, wind speed also calm, and pressure scatter plot shows that stable atmospheric conditions are there, and as it is no surprise. And in the last donut charts we see there is a clear condition all over the way. Overall, this looks like warm and a dry week for Pune. Over to you.
Yes. So here is our project, and I would like to thank Masai for giving this platform, for knowing that how much work we can do and how studious and how focused we are. So yeah, I would like to ask everyone to use our Streamlit app for the forecasted weather and plan your days. Thank you.